Hey everybody, we're going to learn about chemical reactions, and so we're going to look at chemical changes and how to write about them in a chemical reaction. So here's our four objectives for this PowerPoint. Here's what you should do in the book. Do self-check 6.3, page 156, and put that in your notes. You'll like that you did that. Okay. Alright, so what are some evidences of a chemical change? How do you know something chemical's going on? Well, there's an unexpected color change. Look, green and red make this blue. That's unexpected. So changes are what we're looking for a sign of a chemical change. All right, so one thing to look for is an unexpected color change. Also, if heat's given off, there's probably chemical change happening. Maybe, maybe not. If a precipitate forms, keyword precipitate. What is a precipitate? It's a solid formed from two solutions or during a chemical reaction. So look, solution, mix them together and you get this yellow solid. That's a precipitate. If a gas is produced, that's probably a sign of a chemical reaction. If an odor is produced. Not all of these things happen. Not all of these things happen together. If one thing happens, that doesn't necessarily mean chemical, but for a chemical change, you're looking for those major signs to tell you something chemical is going on. Okay, so what is a chemical equation? It's an equation that uses symbols to represent a chemical reaction. Remember this one? Taking you back to bio. Okay, this is carbon dioxide, that's H2O, water. This is sugar, and that's oxygen. Hey, plants make their own food using this chemical reaction. So it's a sentence that uses symbols to tell what's going on in a chemical reaction. Okay, so reactants and products. Reactants are your substances that are the starting materials. They get used up. So when you start a reaction, it's all reactants. When you finish a reaction, they're gone. Okay, because they've turned into products. So reactants are substances that are starting materials. They get used up. Products are new chemicals made in a chemical reaction. New substances that are made in a chemical reaction. So the arrow points to products. So label them. Well, these are the reactants. They're the starting materials. And these are the products. Arrow points to products. So you need to be able to find them. This arrow is your in-between, showing that these turn into those. Okay. So what kind of symbols are we going to use in chemical reactions? Oh, all right. I need to draw that one in there and erase that one. Okay, so please put these into your notes. I know it's going to take a while to write them down, but they're very important. If you see the symbol G in parentheses, it's telling you that that substance is a gas. L in parentheses is a liquid. S in parentheses is a solid. AQ is aqueous, which means dissolved in water. Dissolved in water. Okay. A plus sign on the reactant side is saying reacts with. So this is reactant side of the arrow. All right. It could also always be represented as and. A plus sign means an and. Okay, a down arrow means a precipitate is a product. Okay, so we can use this for precipitate and the product side, or we can use a down arrow, but we can only use a down arrow if it's a precipitate product. An up arrow means gas is produced, so a gas product. The arrow in a chemical reaction, either arrow, all right, means to produce. If you see an arrow, this didn't come out the way I wanted, with something over the arrow, that thing above the arrow is called a catalyst. All right. So a catalyst, heat can be used as a triangle. Heat, these could be a catalyst, so it could be above the arrow. You could have another chemical above the arrow. Any of these things, if it's above the arrow in a chemical reaction, it's a catalyst. Okay. So let's translate this into words. All right. So we have solid. And now we need to name this. Thank goodness we spent so much time writing names. Calcium oxide. Oh, that's an ionic compound. You got it. Plus sign, reacts with. And then this is a G. This is H2. Now you might be wondering, what do I call H2? You call it hydrogen. And in this case, we're calling it gas because there's a G. All right. To produce. That's what the arrow. To produce. That's the arrow. So aqueous, calcium hydroxide. So we have to use all of that naming stuff we've been practicing. We have to use it now, and we might have to use it 2, 3, 4 times in a chemical reaction. All right. So solid calcium oxide reacts with hydrogen gas. This is the plus sign. To produce is the arrow. Aqueous calcium hydroxide. You could also say a solution of calcium hydroxide. All right, so here's one that I want you to put in your notes, and we'll translate it together in class. What if I give you words and I want you to write a chemical equation for it? Well, here we go. Hydrogen gas. So you're thinking H, and you know it's gas. But wait, remember Nafkulbri, huh? Nafkulbri. 7 elements, when they're by themselves, are never really by themselves. They're diatomic. Okay, reacts with plus sign. Oxygen gas. So we know it's O, we know it's gas, and then I look at O is the in Nafkulbri. So I'm going to put O2, and I'm going to put gas. To produce, arrow. All right, gaseous water. So I got water, H2O, and I know it's a gas. All right, now I'm going to put these in, and we'll talk about it in a second. But this goes there, and this goes there. Okay, so I translated these words into this chemical equation. The last thing you do is you put in coefficients to make it balance. We're going to learn about that in a second. Hey, here's another word equation. We'll translate that in class. All right, so matter can't be created or destroyed in chemical reaction. Who says that? Not who. What says that? This law says that. Okay, so if you put something into a chemical reaction, it should weigh the same before and after. Mass of the reactants equals mass of the products. How can that be? Well, if you have atoms that you put into a reaction, you better be able to find them on the other side of the reaction. They might be rearranged, they might have new bonds, but they'll still be there. Okay, so because of that, we have to balance chemical reactions. Well, we don't have to. They are balanced, all right? So if we put in 2 atoms bonded together as green, 1 atom as purple, and they do a chemical reaction, then now there's a chemical bond here and here, but we have 1, 2 green atoms, 1, 2 green atoms, 1 big purple atom. Oh, smiley purple atom. All right. Look, this is a new compound because of the bonding, but all of the atoms are there from left to right. Okay. So every atom needs to be on both sides. So this is C3H8. That's called propane. So here's your 3 carbons. All right. When you go to the product side, you better be able to find those 3 carbons, and here they are. 1, 2, 3. Right? Look, they're bonded to other things though. Here are 8 H's. 1, 2, 3, 4, 5, 6, 7, 8 H's. All right. 2, 4, 6, 8, 10 oxygen on this side. We better find 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 oxygen on that side. So we don't lose or gain any atoms, but notice how differently they're bonded. So we have new substances. Okay. So we're going to now practice balancing as we look at this. Okay. So reactants are on the left side of the arrow. Products are on the right side of the arrow. This is just one product. That's okay. All right, so the arrow is the separator. Now let's count. There's an iron on this side, and there's an iron on that side, even though it's bonded to sulfur. So iron, 1 and 1. One way to balance is to write the atoms down the middle and count. 1 over there, 1 over there. Sulfur, 1 on the left, 1 on the right. This is a balanced chemical equation if there's 1 of each thing in the reaction. Okay, so how do we count atoms? A subscript, all right, tells you how many. All right, so there are 2 carbon atoms in this substance. There they are, 2 carbon atoms, and 6 hydrogen atoms. 1, 2, 3, 4, 5, 6. So everything represents atoms bonded together or not bonded. All right, so subscripts tells you how many atoms are in that compound or element. Okay, so let's count. In this, how many carbon atoms are there? I'm just changing this for later. All right, how many carbon atoms? There's 1. How many oxygen atoms? There's 2. All right, now looking at this, how many nitrogen atoms? Well, there's 1 here, but this says 2, so there's 2 nitrogen atoms. So parentheses, you distribute. Okay, how many oxygen atoms? 3. Carbon atoms, just 1. Hydrogen atoms, well, there's 4 inside the parentheses, but there's 2 of those, so you multiply those, so there are 8 hydrogen atoms. Okay. Potassium atoms, just 1. Manganese atoms, just 1. Oxygen atoms, 4. You have to be able to count these so that we can balance them out. All right, so what's a coefficient? A coefficient is a number or a multiplier that's put in front of a compound or an element to multiply by it. Okay, so if there's a big number 3 in front of something, that means there's 3 of those things. Right. So there's nothing in front of this, which means there's a number 1, so there's only 1 of those. Nothing here means a 1. and 2 here means 2. So what does that mean? All right, so this is H2 bonded together. This is Cl2 bonded together. This is HCl bonded together, but we have 2 of those things. And so then we have 2 H's, 2 H's, 2 Cl's, 2 Cl's. It's a balanced chemical equation. Okay. Coefficients of 1 are implied, so we don't write them in. If it's there one time. If you want it more than once, put a coefficient in front. Okay, so now we have to count again, but this time we have to talk about coefficients. All right, so we said 1 carbon and 2 oxygen, but this 2 means you can write it like this. This is everything. Okay, that's what the coefficient means. So let's count 1, 2 C's and 2, 4 oxygen. All right, let me take this out. How can you do a coefficients? 2 times what's behind it, 2 times what's behind it. All right. How many nitrogen atoms? There's 1, 2 from the inside times 3 is 6. All right. 2 times what's behind it, 2 times what's in the parentheses. So what does this mean? It means this is there 3 times. Okay. All right. So we have 2, 4, 6 nitrogen. All right. So you can write it out if you want, or you can use this as a multiplier. All right. So this is 8 hydrogen. 4 times 2 is 8. Times 3 is 24 hydrogen atoms, 3 carbon atoms, and 9 oxygen atoms. Okay, so make sure you can count them. All right, 6 potassium atoms, 6 manganese atoms, 24 oxygen atoms. All right, so you have to be able to count without a coefficient, and then you have to be able to count with a coefficient. All right, so if I want to balance these, I got to count. I have 2 oxygen on the left, but only 1 oxygen on the right. So I can't change the identity of this. This is water, that's oxygen, that's hydrogen. So I'm going to put a 2 here, so now I have 2 O's on that side. But wait, that makes 4 hydrogen, all right, atoms. So I have to go to this side and put a 2, and I have 4 hydrogen, 2 oxygen, 2 oxygen. Happy balanced equation. We'll try the next one in class. Don't forget about Nafkuber, all right? If those are in chemical reactions and it just calls them their name, don't forget to put 2 next to them because they're diatomic. They hang out with themselves. How do you find them on the PT? Starts with 7, makes a 7, points to hydrogen. 1, 2, 3, 4, 5, 6. 7 diatomics make this word Nafkuber. All right. What state of matter are they? Well, they're all solids. I'm sorry, they're all gases, except for bromine is a liquid, iodine's a solid. All right. So Nafkuber is good. That was silly. Okay, so let's review. All right, when we're talking about chemical changes, you should review how to write and balance chemical equations on page 153. Big numbers in front are coefficients. They're multipliers. Subscripts tell you about the chemical substance, what's in it. All right, you can't change a subscript. All right, H2O is not the same. Sorry, H2O is not H3O. We can't change the bottom numbers. You can't do that. Not allowed. Reactants on the left and the products on the right of the arrow in a chemical reaction. All right, all those things keep in mind. G means gas. All right, L is liquid. Review. Do this. It'll help you. All right, put it in your notes. All right. Don't forget that chemical changes are really fun, okay? So you can make sure you know it, all right? Peace out.